Okay, I'll start recording. Cool. So I'm going to start a new pattern of solving the homework in front of you guys, so you can see like how I would do it, how an implementation works. I should have been doing it the whole time, honestly, because then you have that reference if you're behind as well, and it'll help you catch up. So I'm not going to spend a lot of time talking because you guys all should have done this already, and then the people who need it or whatever, or is interested can slow down the video after. So I'll do day 5 solution.js. So I'm not going to spend a ton of time on this. So first off, I'm going from memory here, but I had to create some pets. So I want those pets to be an object model, so I can say the name. It's an imp. And, get damage is a function. And I need it to return something. So this has, infernal damage of 5. Return this dot infernal damage. And I'm going to say this is actually imp. And then this guy is a demon. This guy has punch damage. And it returns this dot punch damage. And I say my const warlock is going to be name, horsey, level 5, get damage as a function. So you notice that when I do this stuff, I kind of like do the easy parts. You know what I mean? Like I can just write this out, then I can write my get damage function, and it helps me think about it in process. So I'm like, I know my warlock needs pets, but maybe I don't know how to do that yet. But I know I need the get damage function because we talked about that. So I'm like, I'll just write it out like this, and I'll kind of solve it backwards. It's kind of my process. Name is easy, level is easy, get damage is I can at least start it. So I need pets. So now I can go and say pets is an array, and we talked about how I can put stuff in an array like this. And then to get damage, I need to say like let total damage and then loop over the pets. So let I is equal to 0. I is less than pets dot this dot pets dot length. I plus plus. Const pet is equal to this dot pets I. Total damage plus equals pet dot get damage. Plus equals is the same as saying total damage is equal to total damage plus this, right? It's a little syntax helper. So I'll occasionally show you guys stuff like that as I do the solutions, and you can pick up off of miles, all that. And then I return total damage. So now that I have this, I'm usually, before I move on, I would just try and make sure it works. So I'm going to console.log warlock.getDamage and see what that does before I work on. I get not number, and that's because I didn't initialize this to 0. 10. Boom. So already I saved myself headache later because I had a bug here. I didn't say let total damage starts off as 0. So it's nothing, and I was adding to it, which gives NaN, not a number. So I've already kind of saved myself later, shoot myself in the foot with that. So I've got that. And I've got my const warrior, his name, also horsey on both, level 10. Doesn't have pets, but it has get damage. It's a function. And then it's got, sword damage, 7. Return this dot sword damage, boom. All right, and I get a function fight, and it takes attacker, defender. That's kind of stupid, I'll call it character 2. So const C1 damage is equal to character 1 dot get damage. Const C2 damage, character 2 dot get damage. Just console those log out to make sure that they work. Yep. 10 and 7 looks good. Cool. And then I could minus health from them, or I could just do an if statement here. I say like if C1 damage is greater than C2 damage. Console.log C1 else if C1 damage is less than C2 damage. C2 1 else console.log draw. Cool. Character 1-1. That's kind of basically it of how I do the homework. Askgirl asked if I would do an example, a little bit expanding on like summoning pets and how that would work. Say you have like the Warlock has pets, but only summoned pets are active. You actually have to summon the pet before you can use it, really. So if I had that example, I would do something like active pets or summoned pets. Empty array. So this is, just to reiterate, I have pets, but if they're not summoned, they don't do any damage. They're just spells I have, basically, in my spell list. And I have summoned pets. So obviously I'm going to need to change all of this stuff just to summoned pets right out of the gate, because I know I only use summoned pets. But how do I actually summon a pet, right? I would make a summon pet as a function, and it takes a name. And I would do something like, I'll do it with, I could do it in a one-liner. I'll do it in both ways, but I'll do it in the traditional way. I'll be like, for let I is equal to 0, I less than this dot pets dot length, I plus plus. That's pet is equal to this dot pets I. If pet dot name is equal to the name passed into this function, then I want to summon that pet. This dot pets dot push pet. So I loop through all the pets, and if I find one that has the same name as the one I'm summoning, then I push it to my active pets. Sorry, this dot summon pets dot push pet. If I run this, I should have 0 damage. Yeah, you see here I've got 0 damage because now I haven't summoned my pet. So before the fight, I'm going to say warlock.summon pet, and I'll summon imp using its .name property. And now I've got 5 damage because I have a summoned imp, and I will warlock.summon pet, demon, the name. I'll summon the demon. I got 10 damage, boom. So now I have to summon pets. And then maybe I want to like unsummon them after a fight or something. I could do a lot of stuff here. I could also say like, beforehand, I could be like, cannot summon the same pet twice. So I could say for let I equals 0, I less than this dot summon pets dot length, I plus plus. I could say, okay, so now I need to say const pet is equal to this dot summoned pets. I get the individual summoned pet in the loop and say if pet dot name is equal to name. Same thing as before, basically. Throw an error. So now I can't summon the same pet twice. So now if I try and summon warlock.summon pet, imp.name. Boom, got an error. Pet already summoned. That's a quick example. I'm not going to spend too much time or go very slow teaching this stuff because it's just the same stuff we learn, but you can use this video if you want to try and implement this yourself. I saw some people already did, which is cool. I hit record. I did, thank God. So, that's yesterday's homework. So now on to today's stuff. Whoever wants to can watch that. So let's go to day6.js. Okay. Going through, if I go back to the solution here really quick, we have this concept of modeling objects, right? Like, we know that we can have different properties like infernal damage, but we can use functions to return those damage and still have what we call an interface to interact with. As long as we have get damage, we don't care about the other properties here, right? Punch damage, infernal damage. That was yesterday's homework. So what if there was just kind of a better way to model that like out of the gate? And some of you had already done this, and I'm referring to classes. If you haven't, that's fine. I'll go through it slow just like I did the object stuff. But it's largely the same thing, but it's cleaner. You'll see both done. You'll see objects and you'll see this new way. So I'm going to remodel this homework using classes, going through it with you guys. And you go to day 6 and say, okay, I need to create a new type. This type is a pet. It can have a level. Sorry, it can have a damage. It can have a name. This is the same thing our day 5 homework needed. So it's the same thing, where we're having new syntax. And this is more how, a little bit more how real world way you do this example from yesterday. You'd still use those objects for a lot of things, but for this kind of thing, you would do it like this. So I can say class pet. Right off the bat, I can say class pet. This is what the syntax looks like. And I can largely create it the same way I do an object. And it really, under the hood, it is an object. It's more what we call syntactic sugar, which is something that's for the programmer to reason about, because this thing is kind of stupid in a way. It's like it looks kind of random. And every time I want to create a new pet, I need to do all this shit from scratch every time, right? Like I'm kind of redoing the get damage function, right? Redoing the name. I'm not just changing the name on the next one. I recreate the whole object every time. So this solves that problem. So if I say class pet, I have something called a constructor. This constructor is how you create a pet. Sorry, it's the information of what you create a pet. I say const pet is equal to new pet. That's what the creation looks like. So this syntax is the same as yesterday's version of basically saying with no properties. It's the same as this. So far. Just const pet is a new pet, because that's how we initialize classes, is pet. We say the name of it. So we've kind of got the empty equivalent. So I'll keep 2 tabs open and I'll run the object version at the same time. So I'll say this is object.js. So we've got const pet is equal to this, because we know how to do this one on the right. We have this one on the left we're going to do. So I know that when I was writing my other one, I needed to give it like a name, imp, on the right here, right? We did that yesterday. So here what I'd do is I'd pass it in the constructor. Name. And I'd say this.name is equal to name. Constructor is just a function. So the syntax is identical. It's just a built-in one for classes, but it's the same identical syntax, right? Name of the function, brackets, function arguments, the curly brace, and then you have access to this in a class as well, because it is just an object. So if I pass in, imp, and down here I'll console log pet, and I'll console log pet here as well. If I say node day6.js, whoops, I gotta save that bad boy. I see pet with a name of imp. If I console.log, or sorry, if I run the one on the right, object.js, see, I just get name imp. We've already seen an improvement from the class when I'm logging out. I know exactly what I'm dealing with. It's this kind of named class, pet. Now I want to create a second pet over here. Second pet in the object thing on the right, just like we did yesterday, and it's a daemon. Okay, and then I console.log second pet. So I log that out on the right, and I get, name imp, name daemon. Makes sense. Here I can say second pet is equal to new pet, daemon. And I can console.log the second pet. Oops, run node day6.js. Cool. So we have equivalent, something we know on the right and a new way of doing it on the left. So let's keep implementing it. So yesterday I had this, I had the pet has, this imp has like infernal damage. That's 5. And the daemon has punch damage. That's 5. My console log out on the right. See, imp has infernal damage, demon has punch damage. That makes sense. So here I'm just going to say damage. We'll say 5, and we'll say, actually, we'll keep the demon being 7 and the other one 5. And if I log out this, I say pet name, damage of 5. This is damage of 5. You'll notice that when using a class, one of the advantages of the object way on the right is I have this labeling, internal damage and punch damage, which I can't really do in my class.
Wait, Horsey, how come it logged the damage in properly?
Oh, I didn't save it.
Okay.
The little thing up there. Thank you. So I can't name this damage thing differently on the class because it's basically, I think of classes as a factory, okay? That's why I just say new pet, new pet. As soon as you make a class, you have a factory for making these things. You see how much smaller it is? It's one line to make a new pet every time instead of, however many lines the object gets to, which is very clean. But there's always trade-offs in programming. So now I have to call it damage. So now I probably want to do damage type. Pets can do different damage type. I can say this damage type is equal to damage type. And let's say infernal. And let's say punch. Cool. So we're getting there. We're getting to replicate the object stuff. It's starting to look a little bit different. It's starting to look a little bit more organized, in my opinion. So now we have this get damage function on the right. We had get damage as a function. And return this dot infernal damage. And down here, get damage as a function. And we did return this dot punch damage. So it's going to be declared the same way here, outside of the constructor. The constructor only gets run when you say new. New pet, you pass stuff in, that's the constructor. Now all this stuff is set. But here I just say get damage. Looks like this. You don't have to use the function keyword. That's one difference. This is the same as this. You don't have to use the function keyword here. You just use the brackets and it knows. So a little bit of syntax change. And we can say, return this dot damage. So we run it on the right, we have get damage, which is a function. If we run it on the left, we have this, which is not going to log functions, interestingly. You have to call them to be logged here. So I'll say, log pet.get damage. And I get 5. So the interesting thing about this way is if you extrapolate out just kind of what we have now, ignoring these console logs, if I want to make a bunch of pets, right? My guy summons. This is me making about 20 pets. Obviously, you'd change the variable name here, third pet, fourth pet. I'm not going to do it for them all, and this is how little code it takes to make 20 different pets. Now, this is what it looks like with the object way. That's about the same. So we're 169 lines deep versus 30. That's why I think of classes as a factory. Once you set them up and you say how it works, instantiating them is very easy. Creating them is very easy. You just say, give me a new pet from the factory, basically. From the pet factory. So I'll undo all those pastes here, just to kind of show you the advantage of doing it that way. And a lot of the times, if you're not going to create multiple, if you're not going to create multiple ones of something, you got to kind of decide which way you're going to do it. You start to think like a programmer. Like, the stuff that we're doing really lends itself to classes. This game example. You know, you can maybe make 1,000,000 warlocks or warriors. And warlock can have 1,000,000 pets. And if you were creating a game and you wanted to create, you know, we've released the game, we're going to patch in a new pet. Like this way, I think it's a lot better for that. Especially as you get to have 30 functions on one object kind of thing. You know, and I can say class warlock is a constructor, takes name, damage. This dot name is equal to name. Oh, let's take a level. Level is equal to level. This dot damage equal to damage. Same stuff we've been doing, just different spot, right? Constructor is a function, takes arguments. The only difference is you didn't write this function, like, you know, like you do with the other ones, like get damage and fight and stuff. That takes character 1 and character 2. It's just a function. The name is constructor. Classes have them. Nothing more than that. Provides an easy way to initialize something out of your factory for things that need to change every instance of the thing you make in the factory. I can say get damage. It's a function here. And now I'm realizing I need pets. This dot pets is equal to pets. So if I say const warlock is equal to new warlock, and the name is Horsey, and the level is, and you can see now this syntax highlighting in that little block there is telling me all the things I need to create a warlock. It's so nice for the user experience when coding. It says right there, warlock, name, level, damage, pets. So we're going to type the level. It's blue, so, 10. Damage, it does. Now I've realized I don't need damage because I only deal damage with pets as a warlock. So now I'll go to pets, and I'll create an array, and I'll say pet and second pet. And then console.log my warlock. So now you see here, starting here, I get warlock, the name of Horsey, he's level 10, and then pets is, this is the really cool part, an array of pet. Now, for me, for my brain, organizing shit into classes just makes sense. When you begin to log it out, I'm like, oh man, like, this is cool. Like, I'm seeing like the types, like it's a warlock and it's got an array of pets. So if I want to add something to this array, I need to create a new pet. Like, to me, it begins to become very easy in my brain to think of that versus the object way, which is where I'm kind of always like, well, what kind of shit does something need to be a pet? Well, this way with the class, you only ever worry about that one time because every pet you make has this get damage function. You see, I only wrote that once, and over here I wrote it twice. And for every additional pet I make, I have to re-implement this get damage function. It's just fucking annoying. And this, I have this cool template for this factory to make stuff. And then when I log stuff out, it really shows me exactly what I'm doing. Warlocks have arrays of pets. Like, that makes sense for my brain. That is something that that feels more like I'm actually now designing a game, to be honest. It feels like I'm actually, now that I know about this class thing, I can actually sort of define my game. It's very real world. And, objects are good for defining some things. I think, like, kind of the Discord messages, actually, that was a decent example. The server, the channels, the roles and stuff. You might even model that out as classes and find that that's better. But we didn't really need these like interface functions to get damage and stuff there to do with them. And that's kind of where stuff really shines for me with classes. But maybe it is nice. And then say, if we want to go, use our Discord example to do the same thing. And we say class message. And it's a constructor. It's got text and the user. Oh, sorry, not text. This dot text is equal to text. This dot user is equal to user. And I say const message to Dipley is equal to new message. Brackets, it says right there, the blue text in my little highlighting thing. Hey Dip. And now I realize I need a user. So I'll put Horsey in there, but I'll make it first. Now I need class user. And the constructor takes a name and is admin. And this dot name is equal to name. This dot is admin is equal to is admin. Say const Horsey is a user. Horsey, and sure. No, console.log Horsey. Now I've passed Horsey in as my user here. And I say console.log message to Dipley. So we're kind of seeing the benefits here as well. Here's my user. And then now I say, oh, cool, this is type message, class message. And my user is of type user. So I kind of know exactly how to implement that already. If I ever wondered like, oh man, like what argument do I pass in to user? Because like, I don't know, just looking at it, like what do I pass in as for user? You can kind of see. You can log stuff out and be like, yeah, you need type user and it needs a name and is admin to be a user. And if we have functions we expect on them, like let's say add message, and it takes a message. Now let's say this dot message is equal to an empty array. We're going to keep track of this user's messages. We say this dot messages dot push message. We've done that stuff before, pushing to arrays, adding to arrays. This user is going to keep track of all of his own messages. So if we log that out, we're going to see messages as an empty array. But when we create the message in the constructor, we can just call the user's add message function because we know we have a user. And we can pass in this. This is the message. And so now we get something quite interesting. The user, when we log it out, has no messages. Then we have a message. That's where we log out the message to Dipley. It's got, the text. We're used to seeing that. It's got the user. The user's name is Horsey. And it's got a messages array. So after we do that, let's console.log horsey.messages. We can see it's an array here of messages. The interesting thing about this is we've got these kind of like ref and circular things here, which I'm not going to talk too much about, but basically we have a circular reference. The message refers to the user, which refers to the message, which refers to the user, which refers to the message, refers to the user. It's not too much of a problem. I don't want to get into it for now, so you can kind of ignore those logs. But the point is, now every time we make a message, if I say const my second message to Dipley, it's equal to a new message. Hi again, Dip. Horsey. And I console.log horsey.messages. I've got both my messages already. But all I did was make a message. The message creation in the constructor handles adding it to the user via a method on the user. This is a more complicated example of basically what we did before in like day 5 and stuff, where we can rely in this function here on the get damage on the object, right? Because we know that method exists. Sorry, that function exists on character 1 and character 2. That's what we did before. Now we're actually using that to add stuff to the user. And we say, add this, which is the message, via the user add message function, which is up here. So the Discord example works as well. You know, all that is to say is now you've seen 2 ways to do it, 2 different ways. So I'm going to start a new file and kind of go over an example of this from homework. Actually, I'm going to start a new folder, basically start you guys on the homework. I'm going to create a new folder. I'm going to call it game. And down here in my terminal, I'm going to do cd game. And in game, I'm going to write a new class. And it's called warlock.js. Cool. So this is going to have just the class warlock in it. That's kind of where we're going. We got our warlock class just in a warlock file. Okay. And right now, for a contrived example to start off, it just takes a name. And it says this.name is equal to name. Okay. Let's create a new file. And we go to warrior.js. Let's say class warrior. And it has a constructor and it takes a name and it says this.name is equal to name. Cool. Now we're going to have one called game.js. This is where our game logic is going to go. We will put the mechanics of our game here and slowly build it over the next few lessons. So we're going to sort of like starting a new folder and working on a project. We're going to do this stuff a lot to drive it home because I know it's still confusing a lot of people and we're adding this new class thing in now. So we're going to sort of maintain a project, which is why I kind of recommended earlier in the announcements channel to kind of be caught up by now, hopefully by day 5, because it's going to be hard to catch up after this. It'll all be building. So I'm going to teach you the basics of what you need to know to get this done now. And we're going to start setting up a template for our game. I want to create a new warlock in my game. The warlock is not located in this file. The warlock factory, that is. The actual warlock itself should be located in this file. It's the game. How should I go about getting the warlock class from the other file? I got the warlock here, but in this game.js file doesn't know anything about the warlock. I can't say if I try and do this and I run node game.js, I get error warlock is not defined. Before we've had big, long, messy files and we're running them independently. And now I want to set up some structure because we're going to have a proper project and we're going to learn. And it's going to be easier to be organized and figure out where our bugs are if we have these stuff in separate files. And that's how it works in the real world too. So we should start doing it pretty much as soon as possible. I think we're kind of ready. It's not too hard. So in the warlock class, I basically want to do something called exporting it. I want to export it from the file. So I just say module module.exports is equal to warlock. Module.exports just says, it's a magic thing in JavaScript. It just says, what do you want to export from this file so someone else can use it? If you don't export something, it's localized to this file. So now my game needs the warlock, but how do I get it? We say something like const warlock. So it's just a variable. We're just setting a variable like we do before. Const warlock is equal to a require, another built-in JavaScript thing. You can require another file. That one should be a little bit self-explanatory. Whatever this warlock thing does with module exports, whatever that file is, warlock.js, whatever it exports, when I require it, I get that. So it exported the class to me, this warlock, and now game can make warlocks. So if I console.log my warlock, and I pass in a name to the warlock, Horsey. Cool. I can create a warlock and a warrior. Now if I go to my warrior, I got to do the same thing. I got to say module.exports is equal to warrior. And I do it at the bottom of the file after I'm done doing shit, right? So to drill this stuff home, I'm going to make the rest of my classes. I'm going to make a shaman. Class shaman. And it's a constructor. And it's a name. And this dot name is equal to name. Module.exports is equal to shaman. Right? Go back to my game, and I can say const shaman is equal to require dot slash shaman. Dot slash just means in this directory, right? Dot dot in the terminal you've learned before. If you go cd dot dot, it takes you back. And if you cd game, you get in there. And some people are writing code dot in the terminal. Dot means your current folder, so it's the same thing as in terminal when you write code dot to open the folder in VS Code. This is just dot slash, and then slash file paths and stuff. So it's just saying get me the file shaman in the current folder. So now I have shaman as well. Oh, and I can do my warrior. From warrior. Okay, cool. So make a new warrior. This new warrior. Horsey warrior. Console.log the warrior. So now I've got one of each class that I've created. Oops, node. Cool. One of each class created. They're each in their own separate files, tiny little things. And I can export them with module.exports. Module.exports and classes go hand in hand. You can export anything you want from a file. A string, you can export a number, it doesn't matter. It's the only way to stay organized. I hope you guys didn't expect you would be writing entire applications in one file. Because I'll be totally honest about this one. People usually put too much shit in a file. And if you get a job programming, you're going to see some files that have like 2,000 lines. And I keep mine as small as possible. Because it is so easy to find a bug. Be like, oh man, you know what's weird? Is my warlock has a bug, but my warrior doesn't. And it's like, okay, I'm going to scroll through this file and figure out where everything is. Like go back to day5 solutions, like try and figure out where the fucking thing is in this file. Like, what the fuck is going on? Or I just go to warlock.js. The bug with the warlock, probably in the file with the warlock. It might be in game where I create the warlock as well. But most likely it's going to be in the warlock file. And it's going to help keep me organized, and it's going to keep my code readable. And as we continue to make something big, this game may have 20, 25 files. But if they're all small, we get familiar with exporting stuff and creating classes as we go. It's going to be so easy because it's going to be like you'll be helping each other, And it'll be like, man, I'm having a bug with adding a pet to my warlock. And it'll be like, okay, can you show me pet.js? Okay, no, it's not there. Can you show me warlock.js? Because maybe warlock requires it. Same thing here. If we need a pet, we can say pet.js. Class pet. Constructor name. This.name is equal to the name we pass in. And module.exports is equal to pet. We want to export the class pet. Not an instance of it. We didn't create a pet. We just defined what a pet is so that we can make them later with our factory. And this file wants to export that ability. So now my warlock, shaman, pet, and warrior, all in their own files, consumed by one that has my logic, the game, you know. You can put anything in another file. There's no magic here. You're just storing the result in a variable. It's all you're doing with require. You can see const. And it's cool. If I hover over it, it says, look, class warlock, class shaman, class warrior. Like, Visual Studio Code knows what I'm requiring. It's very cool. It's making my job easier, you know, to do this. It's relaxing my brain already to have this in separate files than these big gigantic files we had before, and to have everything organized. So this is the only thing we're learning right now, basically. Classes and require. And the homework's going to be a pretty simple one, day one. And I'm going to do another lecture tomorrow, a little quick one that actually has some proper homework in it. We're going to have a little bit of homework in this too, but mostly it's just going to be about setting up a game folder structure. And you're going to create, you know, all your classes. We're going to create like eight or nine classes that we can play in the game that we want to be. You might be mages, you might be a fucking gambler, I don't know, whatever you can play, whatever you want to have fun with in your game. And as we go through the game, once we have this nice structure set up, we'll be pushing our code up to GitHub to share with each other. And we're going to be using this game template that we've already learned a lot about to be able to learn how projects actually work. File separation like this, pushing code up to Git, not just pasting code into fucking Discord and having someone read it. Like, not that bit, the other bit. No, this bit. No, paste the one above it. You're going to be able to be like, here's my GitHub repo with the code. I just pushed up my latest stuff. Can you help me find the bug? I think it's in warlock.js, right? That's going to be the goal, is to get us working smart. And it's going to reduce the cognitive load. Does anyone have any questions? Overly confusing? You get it? You like it better than the object stuff? It begins to make sense in your head? It makes no sense?
It's so much better.
Yeah.
Just very cool. Very organized.
It
Only
flows
homework
better.
I can get done. I do have one question though. Like, I would assume you can, but like how you're like requiring and doing the module export. Say you're in a warlock folder, right? And you make a pet one. Could you export from like the pet to the warlock, then the warlock to the game? So it's kind of like all linked, like three ways in a sense. You get what I'm saying?
Like this.
Pain.
Now warlock knows about pet, and maybe in the constructor, instead of passing in a pet, I say this.pet is equal to an array. Const imp is, you know, I'll write a comment here. Every warlock starts with an imp as its first pet. So const imp is equal to new pet, and it's an imp. And then this stuff pet stuff push imp. Now warlock knows about pet, can create a new one, because every level 1 warlock starts off with an imp, and it's pushed it. Now, if I go back to my game, and I console.log.warlock, boom, I have a pet imp. And I didn't have to change anything in my game file, just in the warlock file. It's the only thing that I had to know about. I didn't even have to change anything in my pet file. Just have to import it from in warlock. And then now I can start this off with this. Does that kind of answer your question?
Yep.
That's cool. What?
So
Is
if you're trying to do all this in one file, then you'll be scrolling, and right? This is what you avoid when you separate files.
Sorry, what was the question? You're kind of coming through a bit fuzzy. Hello? Can you guys hear me?
Yeah, we hear.
Yeah, we
you.
can
He's just
hear you.
eating a dick. He's eating a dick. It's fine.
Gotcha.
So for module exports, do you always have to put it at the bottom of the file?
If you do not put it at the bottom of the file, you at least need to put it below the declaration of the thing. Like I can't do this because Warlock doesn't exist yet. I'm trying to export something that's created below it. So the standard for programming, and I'm going to make sure you guys do it as well, imports at the top, all your code in the middle, exports at the bottom. Always. Game is the same way. In game, all my imports, I'm importing all this shit with require at the top, then my logic. Shaman has the same thing. It's got my logic here because it has no imports, exports at the bottom. It keeps it very easy to read if all your files look the same. So one of the things I say about programming is the key to becoming a good programmer, becoming super efficient and shit hot, is removing decision. If you remove decisions and you only do it one way, your cognitive load is just getting down to the logic of stuff, right? If you always have your exports at the bottom, always have your logic in the middle, and always have your requires at the top, every file you ever write will look like this. And if you're ever looking for requires and imports at the top, you know where to look for them. And then if you're like, man, I can't seem to get my Warlock out of my game, you'll have to go to your Warlock file and you look at the bottom and be like, oh, I didn't export it. If you start mixing it up, you're just going to have files that are fucking chaos.
Is it standard the way you have the class capitalize the first letter instead of camel case or whatever?
Yes, it is. And it's also like that for requiring classes. So it's not mandatory. I can easily do this. But it's standard to do it with capitals to differentiate.
So if you go back to game.js where the second constant is lowercase Warlock, how does it know which one? Like, is it case sensitive?
No, it's
that line you're hovering over.
This line, remember, this Warlock here that I made, it's not case sensitive. This is the name of my variable that I'm storing my created Warlock in. I could also call this my first Warlock, right? I'm naming that right now. And then I can say const doodlebop is equal to new Warlock. And he's named Doodlebop. There's no relation to the name of my variable when I create something to the name of the class.
You just did it to make it easier to know what you're calling.
Yep, I just called
what you're declaring.
Yeah,
okay,
exactly. I like doing it kind of like that. And then for me, it gets easy to read this as well. I'm like, okay, capital letters are classes. So I need to they're not variables. If I did it like this, I find it very confusing. This reads so much worse to me. You know what I mean? This block now. Because this has the same syntax as kind of my other shit.
And you could also have that
Holy fuck.
that constant declaration just be lowercase Warlock and the call to the class be lowercase. Like it could all be lowercase Warlock.
No,
and it doesn't matter, right?
No, they would clash.
Oh, okay.
You can't both have them because remember up here you're also just saving the result of require Warlock, the file. You're saving that to a variable and because it has const here. So you can't redeclare a variable with the same name. Because otherwise, when I go down here and log it, what does Warlock refer to?
Exactly. That was my question. Okay, good.
Exactly. So you can't redeclare those. I could if I said let. Lets are redeclarable. That's the main difference. But I would never do that here. You know, that's like this is something I would always want to be the same. I'm not going to try and overwrite my class declaration of Warlock.
Cool.
So I know Neil thinks this makes a lot more sense in his brain. For me, it makes a lot more sense in my brain. We're going to make the game with the class way, and we'll use objects for some other stuff, but not definitions of things that are like what I call, with objects, I said we called it the object model, right? That's what I was saying before. The object model. And things that require an object model are often things you're going to make a lot of. Like, I'm going to make a lot of pets and a lot of shamans, a lot of warlocks, warriors. If I'm making World of Warcraft, I have a zillion warriors because I'm the server, and every time a user creates one, I create a new warlock. So it seems much better to me to have that in the class. So we're going to try it with that route. If anyone prefers the object way, they can. We can do more examples with that after, but we will use objects for other stuff. Does anyone have anything else?
One more on the class declaration. It doesn't set the type there. It doesn't set the type until you actually call it, right?
What do you mean?
Because like you have this name equals name. That you don't know that that's a string or a number until you actually
So you're getting
create your first warlock.
You're getting into what is known as TypeScript. JavaScript does not have a concept of typing. It's called weakly typed. In TypeScript, which is a layer over top of JavaScript, you do this. Colon the type. And that way, you know what it is all the time. But you see, if you hover over it, it says here, type annotations can only be used in TypeScript files. We'll probably be doing TypeScript within 2 weeks. I would never, ever write JavaScript without TypeScript. Like in a real world environment. All of my code uses TypeScript because it's safe. You know exactly what stuff is going to be, right?
Yeah, I was curious. Let's start with that. Got sneezers in the house.
Yeah, all good.
Put them down.
Anyone else? Questions, concerns, etc.? Cool. I will pause recording.